Hi guys. So you've watched the video about the history of the numbers and the real number system. I thought that was a really informative video, really well done. So we are going to make this graphic organizer and classify some of the numbers that you use every day, some that you do not. So you could pause the video right now and either print this graphic organizer out that is there for you on Canvas, or you could take a couple of minutes with a ruler and just recreate it. It's really just, a bunch of rectangles. Do take care to make sure you have 1, 2, 3, 4, the square, and then the rectangles. Doesn't really have to be a square, as long as these rectangles are within each other like this, because that is a significant part of the graphic organizer. Basically, anything that is part of this group is also part of the groups outside of it. So it is significant. So pause the video now if you need to create that. Okay. So before we get going on this, I did want to just quickly talk about, and we will do lots more on this very soon, just what a square root is, because I don't really want to start placing square roots in the graphic organizer if you have not seen one or understand what it is. So a square root, when you take the square root of a number, for instance, the square root of 25, what you are looking for is what number times itself, or what number squared, if you've heard that, equals this number under here. So in other words, can you think of a number that the same number multiplied by itself makes 25? And that right there, the same thing means that number squared, that little 2, okay? So I know that 5 times itself, or 5 squared, equals 25. Therefore, the square root of 25 is 5. So let's do another one really quickly. The square root of 16. What number times itself makes 16? Well, I know that 4 squared equals 16. And remember, 4 squared means 4 times 4, not 4 times 2. 4 times 4 is 16. Therefore, the square root of 16 is 4. Okay, that being said, not every number comes out nice and neat like this as a whole number. For instance, I know that the square root of 16 is 4 and the square root of 25 is 5, but what would something like the square root of 20 be? Well, since this falls between 16 and 25, this answer will fall somewhere between 4 and 5, so it'll be 4 point something. So not all square roots, of course, are going to come out nice and neat. In fact, some are really, really messy. Some of them go on forever and never repeat. So if you aren't sure, you should take out a calculator. You have probably one on your phone, or hopefully you have a calculator somewhere that you can use on your Chromebook, and just play around with the square root symbol. So if you take the square root of numbers, you can kind of look at it right away, the answer that it comes out to be, and probably identify whether it's going to be rational or irrational. Okay, so let's classify some numbers. The numbers that I'm about to classify are these numbers right here. Okay, so you could pause the video right now if you felt like writing those down, if you wanted to. You do not have to. But those are the numbers that I'm about to put in my graphic organizer. So you can spruce your graphic organizer up, your real number system, right? So I added a little color to mine, like this, okay? But we are gonna place those into this chart. So let's first start by labeling them all. Okay, the rational numbers is this section here. It is either a rational number or it is an irrational number. Basically, numbers, for the most part, are going to fall under those two categories for you. Within the rational numbers group, right, kind of like when you classify animals, there's the animal kingdom, and then you have, vertebrates and invertebrates, and then you keep going down and down the list. So a rational number has other groups within it. That next one is going to be the integers. A smaller group still contained within the integers, within the rational numbers, is whole numbers. And then an even smaller group within the whole numbers is the natural numbers. We also call those the counting numbers. So actually, I'm going to define just this one, like the guy did in the video. And this is how you define a set of numbers in math, this really fancy bracket. And you show an example. So with natural numbers, you always start with 1 because you would naturally count something. We've used those since the beginning of time. 1, 2, 3, 4. But this is before they even had 0, and you don't start by counting something with 0 anyway. 1, 2, 3, and on and on and on. Those 3 dots mean it goes on forever, and then you do a closed bracket. So that's how you define a set of numbers in math. I'm not going to do that for all of these because you saw it in the video already. Okay. So maybe in pencil, you should pause the video. I'm going to pull this over here. And if you want, you could pause the video now and try to place these in pencil so that you can erase them. That's one option. Place them into the graphic organizer and see if you get it right. I'll stop now for a second so you could pause. If you didn't want to do that, option 2, we'll run through them together pretty quickly, okay? So remember, a rational number is a number that can be written as basically a fraction or a ratio. You see the word ratio, which is a fraction. One number over another, one integer over another integer, where that lower integer cannot be 0. We've already defined this year, right? So in the form of an integer over another integer, where b cannot equal 0, does not equal 0, okay? It could be a negative a over b, but b still cannot equal 0. An irrational number cannot be written in this. You cannot make it look like this, the ratio of 2 integers. There are no 2 numbers, one over the other, that will make these numbers. They're kind of erratic and all over the place. So if you typed some of these square roots into a calculator, you would see that. So a really famous, well-known irrational number is pi. Some of you have worked with that before, I'm sure. So pi is 3.14159, and on and on and on. Goes on, never repeats. Pi is an irrational number. Negative 2/3. Well, negative 2/3 is written already as a ratio, so it belongs, and my colors right now have no rhyme or reason, just making it look nice. Negative 2/3, it can be written obviously as a ratio, so it belongs there. It can't go into the integers. It's certainly not a whole number, and it's definitely not a natural number. Negative 3, where would negative 3 go? Well, it's definitely over here in the rational numbers, but how strict of a category can I put it in? Negative 3 is not a natural number. It's not a whole number because whole numbers do not include the negatives, but it is an integer. Square root of 11 is over here in the irrational numbers. And if you actually typed that in, the square root of 11, it looks messy. It doesn't repeat. You will notice that when the number underneath the square root symbol, when that is prime, the square root of any prime number is an irrational number. For that reason, the square root of 2 belongs here. Square root of 2 is an irrational number. 2 is the only even prime number, because every even number after 2 will have more than 2 factors, 1 itself and 2, right out of the gate. Remember, a prime number is a number that has exactly 2 factors, 1 and itself. So what about the whole number 2? Well, that's part of the natural numbers right here. 1/2. 1/2 is not a natural number or a whole number or an integer, but it definitely is in that other outskirts of the rational numbers. -10/5. I'll pull this over here, see if you can see everything. -10/5. Let's simplify that. What does that simplify to? It simplifies to -2. So when you look at these fractions, think of it as in its simplest form. It looks like it's a ratio, and it can be written as a ratio, which is why it is under the rational number umbrella. But more specifically, it's here in the integers. We want to get as strict as we can. If we could put something here, we would. Okay, but then here, but then here. So we're kind of, it only goes out here if it can't fit into these other smaller boxes. 8/2. That simplifies to 4, the whole number 4. So we'll put that right here. 5/8, not a natural number, whole number, or integer, but it does belong here in the rational numbers. Any fraction will definitely go here, but if it does simplify to an integer or whole number, it might go in one of these two. -4/4. Well, that simplifies to an integer, -1. So -4/4 would be something here. The number 0. 0 is a whole number. Remember, it is not part of the natural numbers. 0.25. I can write 0.25 as 25 hundredths, right? If you say it, you can hear it. Let's write that for a second just to see. 0.25 is the same as 25 hundredths. So that definitely belongs in the rational numbers. Not an integer, a whole number, of course. Square root of 2/3. You would type in 2 divided by 3 and then hit the square root button. That belongs over here in the irrational number category. -0.75. Well, similar to this, -0.75 is really -75/100, which of course we can simplify to 3/4, but it's still a -3/4. It doesn't simplify to a whole number or just an integer, so it belongs here. So -0.75 in the rational number category on the outskirts. -2.5. -2.5 belongs here as well. 0.5 repeating. A repeating decimal can actually be written as a fraction. We are going to start that tomorrow. So this week's remote learning will be changing repeating decimals to fractions. So this is a rational number. You may not know that now, but it does belong here. 0.555, there is some rhyme and reason to it. I can turn it into a ratio of two numbers, so it does not belong in the irrational numbers. Similarly, -0.36 with both the 3/6 repeating, so this would be here in the rational. So that would be 0.36363636, negative, of course. And the last one I'm going to put on the graphic organizer is -4. Negative 4 is a whole number. Oh, sorry, negative 4 is an integer. 4 is a whole number, but once you pull in the negatives, anything with a negative has to either be in the integers or it might be in the rational numbers. It will not be in the whole numbers, and it will not be in the natural numbers. Whole numbers are positive, including 0. Natural numbers are all the positive whole numbers, not including 0. Okay, so hopefully yours looks nice. This was my final one, my first attempt at it. So if you have to pause it and put any of your fractions, decimals, percents, anything in here, actually not percent, sorry, square roots, I meant. If you need to put them in your graphic organizer, here it is in final form.